Okay, I want to look for a second at the error in my notes in P1. And you can kind of see at least how I could make it, because it seems pretty straightforward what I was looking at. When you have a function defined parametrically, so y is some function of t and x is some function of t, if all three derivatives exist, then we can find, and as long as dx dt does not equal 0, then dy dx is just going to be dy dt divided by dx dt. Sorry if that jumped like that. Okay, and so that's just going to be dy dt divided by dx dt. And so what we'll call this is we'll call this y prime. Okay. Now, if the parametric equation defined y as a twice differentiable function of x, we can apply equation 1 to the function dy dx equals y prime to calculate the second derivative as a function of t. And so the second derivative is the derivative with respect to x of y prime. So that what that means is you take the derivative of that function with respect to t, so the one you just calculated with respect to t, and you divide that by dx dt. And so that's a little bit tricky when you're going through the work to get that. It's easy to confuse that. Okay, so this is the problem in the notes that was right for part way through. X equals 6t, y equals the square root of t. So dx dt is just 6, and dy dt is 1/2 t to the negative 1/2. Both these ideas are fine. So your first derivative, which is dy dx, is defined as dy dt divided by dx dt. And so that's exactly what I did. There's your dy dt, and here's your dx dt. And so you get 1/12 the square root, 1 over 12 square roots of t. So, all right. And then I just went through and found the slope by plugging in t equals 1/25. So I simplified that to get 5/12 for the slope. And then get the point, because I want to first write the equation of the line. And so this part's right in the notes. To get the point, I need to find the x and y coordinate when t is 1/25. So I'll get 6/25 for x and then 1/5 for y. And then I can just go through and write it's y minus y1 equals m onto x minus x1 and simplify. So this is fine. What happened in my notes is right here when I was calculating dy prime dt. So what I should have done to get that, to get dy prime dt, is actually take the derivative of my dy dx. But instead, I took the derivative of this, I took the derivative again of this dy dt. And so that's where I get the negative 1/4, this is a 4, negative 1/4 t to the negative 3/2. So that's actually completely incorrect. So what I should have actually done is go ahead and look at my dy dx was that 1 over 12 square roots of t, which is 1/12 t to the negative 1/2. If I take the derivative of that with respect to t, that then will be, because this is what we call y prime, so the derivative of that with respect to t is the numerator that I need in that second derivative. That's going to be negative 1/24 t to the negative 1/2 minus 1, which is negative 3/2. And then to find the second derivative, I'll come over here. It is defined as that dy prime dt divided by dx dt. So I should have done this negative 1/24 t to the negative 3/2 divided by dx dt, which was 6. And t here was 1/25. So if we just flip it and say 25 to the 3/2, that'll clean this up. So it's going to be negative, and this 24 can go on the bottom to live with live with a 6. So that's going to be 144 in the denominator. And then this is going to be 25 to the 3/2, which is 5 cubed or 125. So negative 125 over 144 should have been the answer for that problem, not the answer that I got. And just to help you, or just to kind of verify, I went online and had it generate a problem and did it the way that I'm now describing, and it did work correctly. So these answers were considered correct. They gave me the yes. So just let's walk through it real quickly. Dx dt is going to be 3. dy dt is going to be equal to 1/2 t to the negative 1/2. When t equals 1/25, dx dt, of course, is 3. dy dt is going to, so we need dy dx, which is defined as dy dt divided by dx dt. So in this case, that's going to be the 1/2 t to the negative 1/2 divided by dx dt, which was 3. So this is 1/6 on the square root of t. Now, when you evaluate that at 1/25, the square root of 1/25 is 1/5, but in the bottom, that's like putting the 5 up top. So this is going to be equal to 5/6. So that's your slope, is your 5/6. Your point, when you plug t 1/25 in for t, your x-coordinate is going to be 3/25, and your y-coordinate is going to be the square root of 1/25, which is 1/5. So your formula, remember your formula is y minus y1 equals m onto x minus x1. So it's going to be y minus 1/5 equals 5/6 onto x minus 3/25. And let's see, 3 goes into 6 2 times, 5 goes into 25 5 times. Don't forget to multiply the 5/6 through there. So this is 1/5 equals, let's see, this will be 5/6x, and then that's minus 1/10. And you move the 1/5 over, and that'll give you the plus 1/10. So y equals 5/6x plus 1/10. That part's all straightforward. Should have been able to get that part from the notes. But it's the second part that's a little bit trickier. Your dy dx you found to be the 1/6 square root t. It is this that you take the derivative of with respect to t. So it's this thing that you're going to take the derivative of and divide that then by dx dt. So the derivative of this, let's see, this is 1/6 t to the negative 1/2. So that's going to be negative 1/12 t to the negative 1/2 minus 1. So that's going to be negative 3/2. And you're going to divide that by dx dt, which was 3. So this is negative 1/36 t to the negative 3/2. Then when you plug in t equals 1/25, if you plug in 1/25 into the negative 3/2, that's the same as saying 25 to the positive 3/2. So this is negative 1/36 times 25 to the positive 3/2, which is 5. The square root of 5 is square root of 25 is 5, cubed is 125. So negative 125 over 36 is the correct answer. So it's kind of a subtle little mistake I made there, but it definitely could be quite frustrating. So when you're finding the second derivative, your numerator is the derivative with respect to t of your first derivative.